Hello, my name is Brandon, and welcome to the next video in my series on basic statistics. If you're new to the channel, it is great to have you. Welcome. If you're a returning viewer, it is great to have you back. If you like the video, please subscribe, give it a thumbs up, and share it with classmates, colleagues, or friends, or anyone else you think might benefit from watching. So now that we are introduced, let's go ahead and get started. So this video is technically part 2 of the previous video. In the previous video in this playlist, we learned about how to find the mean of grouped frequencies. And as you can see here in this video, we're going to learn how to find the standard deviation of grouped frequencies. So if you want, you may want to go back and watch the previous video before watching this one. Because in this video, while I will go over a quick summary, I'm not going to cover everything as I did before. So let's go ahead and get started. So here's some information from the previous video where we found the mean of grouped frequencies. As you can see, we have 10 equally spaced bins of salaries. So our lower bin is a salary of $20,000 to $30,000, and then we found the midpoint of that bin, which of course is halfway between, which is $25,000, and we had 30 observations in that bin. Same is true for the rest of the bins. So $30,000 to $40,000, the midpoint is $35,000, and we had 20 observations in that bin, and so on and so forth. So the mean frequency, just to reiterate what we did before, we multiply each midpoint by its frequency. This is a weighting process. Step 2, we sum all the values from that first step. And then in step 3, we divide the sum from step 2 by the overall number of observations, which in this case was 200. So here's a quick example. To find the mean frequency, so for the first bin of $20,000 to $30,000, the midpoint was $25,000, the frequency was 30, so we have 25,000 times 30, and that is our mean frequency for that bin. Okay, so now on to the new stuff. So to find the standard deviation of grouped frequencies, it's very similar to how we calculate standard deviation for just regular quantitative data. So it goes like this. So where, in this formula, the term m, the midpoint, minus x bar, which is the mean, squared, is the square deviation between the midpoint and the mean. So m minus x bar squared is that squared difference between midpoint and overall mean. F is the frequency of that bin or group. We saw that in the previous table. The summation symbol states that we add together all of those products. So we take m minus x bar squared, multiply it by f, we get a value. Then we do it again for the next bin, and the next bin, and the next bin, and then we add all those together. And the term n minus 1 is the sample size minus 1. So this is actually similar to the typical standard deviation calculation we might do for other quantitative data. So remember, whenever we talk about standard deviation, we're also talking about the variance. So if we were to remove the square root symbol up above, we would have s squared equals the variance. So this is how our table looks when we do that. I'm not going to go through every row, of course, but you can see here on the right-hand column, this says f times m minus x bar squared. Remember, multiplication can go either way, so the f can be at the beginning or it can be at the end. It doesn't matter. So here we have 30, which is our frequency, times the squared difference, the squared deviation between the midpoint, in this case 25,000, minus 68,300, which is the overall mean that we found in the previous video. So as you can see, the pattern holds true as we go on down the right-hand column there. And then of course, our summation symbol would tell us to add all those up. Now I know from doing this that that number is huge. Okay, we're dealing with very large numbers here. So the sum of all those values is extremely large. I'm not going to go ahead and write it down here. Just trust me on this one. So what are the results if we went ahead and did all that math out? So the salary standard deviation using these grouped frequencies is $29,384. Now we did not have any of the original observations. We were strictly using those grouped frequencies. Now, I kind of lied like I did in the previous video. I do have the original data. So the standard deviation of the original data is $29,488. Look how close that is to the standard deviation at the top. So in terms of accuracy, this is a very quick and rough calculation for accuracy. We can see that we are about 99.65% accurate when using the standard deviation from the grouped frequency method there at the top to the actual standard deviation we have down here in the middle. That is extremely close when we're only using grouped frequencies or a histogram. So to sum up both the first video and this one for the mean and the standard deviation. So for the mean, in the actual data, we have a mean of $68,403. For the grouped data that we're using here, the mean was $68,300. So it's an accuracy of 99.85%. For the standard deviation, for the actual data, was $29,488. For the grouped data, it was $29,384. That accuracy was 99.65%. So as you can see, the grouped data calculations are extremely close to the actual data values. So a few things that help for this problem. The data set here is actually pretty large, so it was 200 observations. Therefore, each bin had an adequate representation in it, so an adequate weighting in the grouped calculations. The bins were close in the number of observations inside each bin, so they were all between 14 and 30 observations. So why does this work? So again, this is kind of a mix of the first video and this one. We'll put it all together. So think of each bin as its own sample of the overall data. So each little bin, whether it's 14 or 30 or however many it is, that's its own little sample. That sample contains only the values in that bin. What we know is that if we were able to take the mean of just the data in that bin, the result would be close to the actual mean, that is, the midpoint. So we are estimating that within each bin, on average, the values converge around the midpoint. So the frequency weights the midpoint for each bin. And therefore we use the midpoint as sort of a stand-in for the observations we do not know, which is pretty cool. So we are summing the squared deviations, in this case, in this video, weighted by the frequency, and then taking the square root. Almost the exact same as non-grouped data when we're finding standard deviation. Okay, so that wraps up our quick video on how to find the standard deviation for grouped frequencies. Again, you can see this video as a companion to the first video where we found the mean, and this one we found the standard deviation. Again, both of these techniques can be very helpful when you don't have the actual data. You may only have a data table with frequencies, or you may only have a histogram. But as long as you have that, you can go ahead and find a pretty accurate mean and a pretty accurate standard deviation just based off that grouped data. So thank you very much for watching. I appreciate your time, and I look forward to seeing you again in the next video. Take care.